Hello everybody, I'm Gandy Rosales. I will be presenting the mesoscale oceanography and intelligent analysis for the sustainable fisheries optimization. But before that, I would like to introduce myself. My background is in oceanography, in physical oceanography and fisheries oceanography. I earned my PhD degree from the Tokyo University of Marine Science and Technology here in Japan. And before that, my master degree from across 3 different universities in France, Spain, and in the UK. I also would like to mention that I've been working studying the Peruvian fishery sector, including I participated also in several international projects between Japan and Peru in the same topic of the fisheries and the impact of El Niño South Oscillation in the Peruvian fisheries sector. So I've worked before with the giant squid, the Peruvian hake, and the Peruvian anchovy, and the relationship with these mesoscale eddies in the Peruvian area. No? So the core of my work involves highly precise methodology for detecting and tracking eddies that originate in the coastal region and move around, and have distinguished characteristics, and they can trap nutrients, they can move them around, and that's why these structures are very important. So, but I would like to also mention and emphasize that this methodology has been implemented from another system, which what my professor was working with in the publication already published paper from 2015 for the California system. So we adapted this methodology and successfully applied to the Peruvian area, and meaning that this methodology can actually be applied, implemented to other ocean systems. So, the current problem. What is the current problem? Most fisheries companies have the same issue of excessive search time, which means that the captains sometimes they don't know where to go, which are the best areas, or based on oceanographic data to know where most likely I will find, or they will find the target species, which implies a lot or high operational cost. And since they don't have clear where to go, they makes this decision-making uncertainty, and overall this has an impact on the stability of the company related to the production and the costs. That's why the goal of this study is to sustainably optimize the fishing campaigns by stabilizing catches, reduce search time, and decreasing the fuel consumption. To do so, we apply this methodology. First, we collect the data. We obtain data from Marine Copernicus reanalysis data, which is a global platform to obtain variables like velocity, UMB, at high resolution. And from AcruxSoft, we have also the biogeochemical data, which are at highest resolution, like SST, salinity, chlorophyll, oxygen, and all of these we validated for with available in situ data. So what do we do with this methodology that we're gonna develop in this area? So first, we calculate with this simple equation here. We calculate the eddy kinetic energy, which is a very interesting and important variable for measuring the energy of the eddies. And then we do the eddy detection and tracking for detecting the eddy. So to be able to detect the eddy, what we do is we calculate these equations, which is the Oku-wise parameter, which means that this equation makes you classify those structures that are rotating structures from deformation structures. No? So when in the ocean, this equation, what it does is mainly recognizing centers or rotating regiments. No? When the Oku-Wise parameter is lower than 0, and otherwise it just the model, what it does is just not taken into account. And then after detecting the eddy, what we do is differentiate them between whether they are cyclonic or whether they are anticyclonic. No, for instance, in the southern hemisphere, in the Peruvian area, we have this equation which is called zeta, and we find anticyclonics in cyclonic eddies, which have warm core and cold core, depending on which hemisphere you are. But basically, these two equations for detecting and later tracking the eddies. So how does this work? So first, as I mentioned in the methodology, we quantify the eddy kinetic energy. In this specific example of a case study of Peru, we were interested in differentiating the layers, the surface from the subsurface. Subsurface here, we're talking about like 100 to 200 meters. And we wanted to see what are the difference in this specific area for studying later another species like to compare with the giant squid. So what we found here is that in the surface layer in the Peruvian area, we have very strong and enhanced eddy kinetic energy in the central region than compared to the subsurface that is more located in the southernmost region, which is a very important and critical results, because we were trying to find out why were so much migration of this giant squid in this area, specifically in this southern area. But we not only use this eddy kinetic energy as average values, but also as a seasonal analysis and as interannual analysis, which can give you a much interesting results when you compare with fisheries, because this variable tells you like where the eddies are much stronger, where are they going, how are they moving, etc. So by knowing where the eddies are going, where are they, and where will be the most likely areas that they will be abundant, and etc., we, as you can see here with the methodology of the detection and tracking, we also detect in the same region where we first found the most abundant eddy kinetic energy, which is the southernmost region. So here what we did is detect 4 different eddies to see how do they interact with the region, and how do they move. So in this movie, I hope it works this time. Yes, it works. It's working. So in this movie, you will see those eddies detected here in the coastal region moving offshore, and eventually going to the northern part. So this very interesting way to analyze the eddies is helps you to understand how, where, and when they are happening. So for instance, in this specific example, we have that eddy that was generated in the very coastal region, and here in these other panels that are nutrients. You can see here in these yellow colors and blue colors and red colors are telling you the concentration of the nutrients within the eddy. So this is a section within the eddy that we detected here in the coast, and within this eddy that we call PUDI A1, we have a very high or a strong concentration of nitrate, which is very yellow colors here in this part when it detaches from the coast. And this one, after 1 month, is still there. You can see it here. This is a second panel of 1 month after, and you can see the high concentration nutrient nutrient values here within the eddy. This is the within the eddy, but because we are considering here eddies, subsurface eddies, which are like 100 to 200 meters, and you can see that within the core of the eddy, they are trapping nutrients within the core and moving it within around, as you can see also in the video here, moving around, and also the concentration of nitrate. So in this study, what we prove is that eddies that are generated next to the or originated next to the coastal area, they can trap nutrients within their core and move them around, move them offshore, or eventually, in this case, eventually norther than the original point, trapping these nutrients and recirculating this concentration of nitrate to other regions, no? So this is a very interesting point, results, because then after that, what we did was comparing these results of the eddies with squid data. So third, what we do in this methodology is ensemble all the detected eddies within the years. No, for instance, for this specific case of the giant squid, we were very lucky actually to have this data. We had like 2015, 2016, and 2017 data for CPUE, which is, you can see here in the bottom table, you can see the CPUE values of these specific years and for each type of El Niño. So what we did here, the first row, second row, third row, we have different years, and along the columns we have different type of eddies. For instance, the first column is the cyclonic eddies, then we have the anticyclonic eddies, and then again we have subsurface cyclonic and subsurface anticyclonic. So what we did here is detect the eddies within the same region, and within the same region that we obtain these CPUE values, we analyze where the CPUE values were found, were highest, were abundant, and we compare that with the detected eddy to see why they were abundant. No, so we found here in these specific results, this specific data of Peru, that the giant squid is actually very much they like these warm conditions, because during 2015, you can see here in this table, in 2015 we had El Niño, a very strong El Niño in 2015, and within this year we had like almost all eddies had a very high CPUE. No, we found that this species was very much attracted to surface anticyclonic eddies and surface cyclonic eddies, and also subsurface, very interesting, subsurface cyclonic eddies. So it's well known that this species, giant squid, they can actually have a very high migrations from the surface to the subsurface, and even go further deep. I remember one research, they found this species more or less around 800 meters in the Peruvian area. So they are species that can actually highly migrate vertically. So when they have conditions that they like warm waters, they stay there, and they have a very high CPUE values. But when El Niño was ending in 2016, for instance, then El Niño was already going down, and colder conditions were coming back to the boiling region, and then the CPUE automatically decreases a bit. And then 2017, which was a very short El Niño, coastal El Niño, which did not have a great impact, like for instance 2015, then there was the lowest values of CPUE, as you can observe here. So it's very interesting to compare this oceanographic data, the eddy detection, with the species in situ to see how do they respond to these not only environmental changes like El Nino events, but also where is most likely to find them, to find most abundance of this species by studying El Nino, by studying the eddies, which we can also observe here that they most likely prefer the surface cyclonic and anticyclonic eddies, and they also like warm conditions like El Nino events. So what would be the benefit of applying this new methodology, which is not really or has not been implemented yet anywhere? In Peru, at least, we are working right now with the university, my university, La Molina National Agrarian University. We are trying to implement this methodology to other companies and other universities that also do the research with mesoscale eddies, but so far they haven't yet implemented. In Japan, we already do this in here, no? And that's why they have very good results for catches and research related to the eddies. So the benefit of applying this or implementing this methodology would be the increased catch stability, no, by predicting where likely the food will be trapped and moving around. So as I mentioned before, within the eddies, their main goal is trapping these nutrients and moving them around. So these nutrients are the most important fuel for primary production. So if you know where those eddies that are trapping nutrients are, then you will know where the food is. So these species will just migrate or move around according to the environment and where the food is, the availability. So that's one point. And the competitive advantage by incorporating this scientific knowledge to reduce uncertainty. Now for captains, and they will have a more strategic planning rather than just a random search. So they will be more informed to where to go, the decision making. And the sustainable management of the resources, of course, by understanding their biological cycles, migration patterns, and responses to the environmental changes due to the climate change. So this is a very important point, because by understanding the species, by understanding the migration, by understanding the changes, we can actually plan where to catch, when to catch, and when not to. So we can also strategically plan how these changes of, for instance, climate change, which is very much happening already, might affect our production. How might affect not only because of the fisheries, but also because of the bad conditions, bad weathers, and etc. So these are the benefits of applying this new methodology. So thank you very much, and I would like to hear your thoughts. Thank you.